My dear students, so today system of particles rotational motion problems I'll explain. High weightage chapter one more. So for NEET, KSET, MSET, for NEET point of view, high weightage chapter 3 to 4 questions compulsory. Yes, system of particles rotatory motion. Very first question. A bob of mass is m attached to a inextensible string of length is L suspended from vertical support. The bob rotates in horizontal circle with uniform angular velocity. Yes, students. So if it is rotating horizontal circle with uniform angular velocity omega given. Okay. Questions. There is only change in magnitude of angular momentum. Magnitude of angular momentum no change, students. Angular momentum L equal to r cross m into v. Wherever you consider here velocity vector and position vector mutually perpendicular, wherever you consider, so perpendicular velocity vector and position vector, it is perpendicular only. That means magnitude of L is no change, students. Actually L is constant. L equal to mvr, it is constant only. V is perpendicular all cases. So that means it is wrong only. So there is only change in direction of angular momentum. Yes, it is okay, students. Angular momentum direction wherever you consider, direction of angular momentum is changes. Angular momentum magnitude is mvr, it is constant only. But direction here, direction is changes. So change in direction of angular momentum, yes, option 2 is correct, students, here. Yes, first question, theory question, little easy only. Next, a thin uniform rod of length is L and mass is m, swinging freely about horizontal axis, passing through its end. If its center of mass rises to maximum height h, then maximum angular speed. Little application question, students. Now see, rod here, rod of length is L is given. So it is oscillating. It is oscillating from their mean position to and from motion about a fixed point. Okay. So for example, this rod center of mass here it is located. So while moving upward, center of mass position not here fixed, no? Center of mass position, for example, this is the new center of mass position. This rod new center of mass position. This vertical height is given. This vertical height is given capital H. Vertical height, center of mass vertical height, capital H. Maximum angular speed. Students, here conservation of energy, students. So initially rod, now at this position rod potential energy equal to rotational kinetic energy. Conservation of energy related question. So what is potential energy? You know very well, potential energy depends only vertical height. So potential energy of uniform rod mg capital H equal to rotational kinetic energy half I omega square. So now this rod is rotating about which axis? About this axis of rotation. Yes, that means this rod related one end of the rod. You know moment of inertia one end of the rod, mg capital H equal to half I is ml square by 3 one end into omega square. So now this m is cancelled. 3 into 2 6 gh. So 6 gh by L square equal to omega square. Omega equal to under root 6g capital H by L square. It is given second option, students. I think it's clear. Conservation of energy related. So potential energy equal to rotational kinetic energy. Potential energy mgh equal to half I omega square. Yes, students, I think clear, it is important. Next, a wheel is rotating at 10 revolutions per minute per second is brought to rest in 4 seconds. So final angular velocity 0 after 4 seconds. Average angular deceleration. So asking, it is easy only, students. So final angular velocity omega f equal to initial angular velocity minus alpha t Kinematic equations, rotational motion. Yes. Final angular velocity becomes 0 after 4 seconds. Initial angular velocity directly not given, 10 revolutions per minute. So n equal to 10 revolutions per second. So now angular frequency omega equal to 2 pi n. So 2 pi into 10, that means 20 pi. So 20 pi is initial angular velocity minus alpha into t is 4 seconds given in the question. This alpha only asking, minus alpha only asking. So 4 into alpha equal to 20 into pi, direct only students. So 4 here, 5, alpha equal to 5 pi. So deceleration minus alpha equal to 5 pi students. So option 4 is correct. Now this is easy formula based question only. Yes students, next question, moment of inertia related question. The moment of inertia of circular disc of mass is capital M and diameter is capital D about an axis passing through center perpendicular to its plane. Formulas very important students. Uniform ring, disc, hollow sphere, solid sphere, uniform rod, hollow cylinder, solid cylinder. These are all formulas very important. So now here uniform disc, mass is capital M given, D is diameter. So diameter is capital D, radius is nothing but D by 2. Radius R equal to, in terms of diameter, D by 2. Question here, what is moment of inertia about an axis passing through center perpendicular to its plane? So that means about this axis, this disc is rotating students. About this axis asking. Moment of inertia about passing through center of mass, actual formula is mr square by 2, but r equal to here d by 2. So r equal to d by 2 substitute here, m into d square by 4 into 2, that means moment of inertia m d square by 8. Formula based question, first one only. I think it's clear. Moment of inertia about center of mass mr square by 2, about any tangential perpendicular is 3 mr square by 2, along the diameter mr square by 4, tangential parallel is 5 mr square by 4. Formula based question students. Yes. Next question. The shape of graph between angular momentum and rotational kinetic energy of rigid body. Little easy students. So now formula based question. Kinetic energy and angular momentum relation. Kinetic energy equal to L square by 2 into I students. How it will come is nothing but normal translational kinetic energy K equal to P square by 2m. So here P is nothing but angular momentum L, linear momentum, angular momentum. So rotational analog of mass is moment of inertia I. So kinetic energy equal to L square by 2I. What is the relation between kinetic energy and L square means Ke is directly proportional to L square. Directly proportional to L square, power more than 1. Many times I explained. Parabola students. If it is more than 1 is nothing but parabola. 1 is nothing but straight line. Yes, I think this problem is clear everyone. Next question. Rotational analog of equation of F equal to d by dt. Translational motion, force, rotational motion, here it is torque. Direct only students, torque tau equal to, so d by dt of rotational analog of linear momentum is angular momentum. So tau equal to dl by dt, first option only given. Easy students. Next question, little difficult, please concentrate. Now a block of mass m is supported by massless string wound around uniform solid cylinder of mass is m, radius is r. If the string does not slip on cylinder, then acceleration which block falls. Just listen carefully students. Here block is accelerated means how many forces acting this block? First mg is acting downward direction. Now here tension in the string, tensional force acting upwards. because of this acceleration A. So acceleration A equal to mass into acceleration net force equal to, here, so mg minus tensional force equal to mass into acceleration. Free body diagram, very well this one. So tensional force, how to calculate, that is very important, students. Rotational motion, so it is accelerated, angular acceleration alpha of this disk, angular acceleration is alpha. So what is the torque is nothing but, torque tau equal to I into alpha. Now torque tau is nothing but force into perpendicular distance. Listen careful. Here force is tensional force. Perpendicular distance means this is perpendicular distance, students. What is torque is nothing but force into perpendicular distance, F into R. But here F is nothing but T into R, tensional force, equal to I is moment of inertia. Moment of inertia I is, so just here torque is nothing but, why confusion, torque tau equal to force into perpendicular distance equal to moment of inertia about this axis of rotation, students. It is solid cylinder. Solid cylinder means it is made up of disc only, students. So disc, what is the moment of inertia? Just now above problem we discussed, mr square by 2 into alpha is nothing but, in terms of linear acceleration, a by r, students. Linear acceleration, angular acceleration relation, a equal to r alpha. So alpha equal to a by r, just I substituted here. That's all. So now here one r is cancelled, this r also cancelled. What is tensional force is nothing but ma by 2. So mass of the disc also small m only given. So ma by 2 is tension in the string. That's all. So rotational motion, torque tau equal to I alpha. From that we calculated tensional force. This tensional force substitute in equation 1. So mg minus ma by 2 equal to ma. So now here mg equal to ma plus ma by 2, normal simplification. So 2 ma plus ma, 3 ma by 2. So m is cancel only, students. Acceleration A equal to 2g by 3. So this is given option 1, students. Clear? So important question, rank deciding question. Now seat deciding questions also. Very, very important, students. These model questions please practice. Okay? Rotational motion. Next, the value of a cross b whole square plus a dot b whole square. Easy, students, it is. A cross b, cross product ab sin theta whole square plus a dot b is nothing but ab cos theta. Dot product is ab cos theta whole square. Normal only. So a square b square sin square theta plus a square b square cos square theta. So these two terms common is a square b square. Sin square theta plus cos square theta, one only. Answer is a square b square, given fourth option. Easy, students. Next, two balls are thrown simultaneously in air. The acceleration of center of mass of the two balls while air. It is important, students. Please concentrate. Now here two balls thrown simultaneously, center of mass. So center of mass ACM equal to m1a1 plus m2a2 by m1 plus m2. Just two balls of different masses, students. Two balls thrown simultaneously. See, for example, m1 ball thrown vertically upward, but acceleration due to gravity acts downward only. m2 second ball, it is also thrown vertically upward, but acceleration due to gravity acts vertically downwards. Just value substitution only, students. Acceleration of center of mass equal to m1 a1. a1 is nothing but minus g j cap, downward direction. So minus m1 g j cap minus m2 g j cap, second also downward direction only, by m1 plus m2. Easy students. So these two terms here minus g j cap common is nothing but m1 plus m2. So numerator m1 plus m2, denominator m1 plus m2 cancel. Acceleration of center of mass equal to, you will get minus g into j cap only. So what is acceleration of center of mass? It is equal to g only. Very important students. So depends on masses of the balls? No. m1 plus m2 cancel only. Third option is wrong. Important question. Next. So the instantaneous angular position of point on rotating wheel is given. Angular displacement is given, students. Theta equal to 2t cube minus 6t square radians. Okay. Question here. The magnitude of angular velocity at the instant when angular acceleration becomes 0. 2 time differentiation. 1 time differentiation angular velocity 2 into 3 6t square minus 12t. Angular acceleration alpha equal to 12t minus 12. This is equal to 0. After what time equal to 0? T equal to 1 only. So t equal to 1, substitute here, you will get angular velocity. So angular velocity when angular acceleration equal to 0. T equal to 1, substitute here. So angular velocity is 6 into 1 minus 12 into 1. So 6 minus 12 is nothing but minus 6 radians per second. So but here magnitude of angular velocity asking, so plus 6 radians per second, fourth option. Clear students? See differentiation, integration, how important physics. Next, a rope wound around hollow cylinder of mass is 5 kg and radius is 20 centimeter. If rope is pulled with force 20 newtons, the angular acceleration of cylinder, important students. So here hollow cylinder, again hollow cylinder made up of rings, students. Solid cylinder made up of disc. So hollow cylinder of mass is given 5 kg. Okay. Radius is 20 centimeter given. R is 20 centimeter. 20 centimeters converted to meters. 1 by 5 meter. So 1 centimeters 10 to the power of minus 2. I think you know very well. 1 by 5 meters. Okay. So here 20 Newton force is acting, students. 20 Newton force acting. Angular acceleration. Normal, students. Now here torque tau equal to rotation motion, torque tau equal to I into alpha, angular acceleration. Torque tau is nothing but force into perpendicular distance. So here force is nothing but 20 newtons, torque tau. Perpendicular distance is nothing but here perpendicular distance radius only 1 by 5 meters equal to moment of inertia I. I is nothing but moment of inertia. Moment of inertia ring, students, mr square. M is nothing but 5 kg. R square. What is R is nothing but 1 by 5 whole square into alpha. Angular acceleration asking. So here 1 5 is cancelled. So 5 here 4. So now here alpha equal to 4 into 5, students, 20 radians per second square, given option 1, students. I think it's clear only, students. Torque tau equal to I into alpha. I is force into perpendicular distance. Force is given 20 newtons. Perpendicular distance convert into meters 1 by 5. Yes, students. Next question. A frame made by joining two uniform rods, each of mass is m, length is l, as shown in diagram. Coordinates of center of mass of system. Little easy, students. So here rod of length l, you know center of mass is located here. This rod also uniform rod, center of mass located here. So these two centers, center of mass is located here. Correct? Exactly midpoint. Position of center of mass of these two rods asking. This is the position, students. So total is L here, up to here, L by 2 here, up to here, L by 4 here. So L now here this position is L by 4 comma L by 4, it is easy, only fourth option given. Yes students. Next, for a system to be rotational equilibrium, the torques acting on must be 0. This is true only, very important students. So the center of the system only, oh no students, the center of mass of the system, any point on the system, not only any point on the system or outside the system also. So torque tau equal to dl by dt. Torque 0 is nothing but, so it is true any point on the system or outside the system also students. Theory question, it is easy only. Next, child stands at center of turntable with his two arms outstretched. So this is easy only students. Law of conservation of angular momentum related questions, you know very well. If there is no external torque acting on the system, angular momentum L is constant. Angular momentum L is constant means I1 omega 1 equal to I2 omega 2. Now here I1 it is okay. Omega 1 first is given 40 radians per second. So stretching outside given equal to angular speed of child, he folds his hands, reducing moment of inertia 4 by 5 times. So I2 equal to 4 by 5 times of I1. Omega 2 is asking. Easy only students. Now this I1 is cancelled. 5 into, now here 4, 10. 5 into 10 is nothing but omega 2 equal to 50 radians per second. So these model question also repeatedly asking students. So if there is no external torque acting on the system, rotational equilibrium, angular momentum of system of particles remains constant, L equal to constant, I1 omega 1 equal to I2 omega 2. Okay students. Thank you students. Continuation problems, one more video I will explain. So if really you feel it is useful videos, please like, share and subscribe my channel students. Thank you so much.